Good morning to Dr. Asmala. So, our project for image processing and pattern recognition consists of three members, which is me, myself, Surya Varman, and then another member is Yogesh, and then another member is Purushendra Naidu. So, our title for the project is face texture recognition. So, our problem statement will be the goal of is to develop an automated system that can recognize and distinguish between patches of dry and oily skin in face photographs. The technology provides comprehensive insights into skin properties by enhancing, smoothing, and segmenting the skin areas using sophisticated image processing algorithms. Our objective will be to enable automated skin analysis, and then our second objective is to identify skin types using advanced image processing techniques. And then our third objective will be to empower consumers with skincare knowledge. And then our last objective will be support dermatological research.
Our flowchart, and the first process will be to initiate the process, and the second one will be load the image. So the third one will be to convert to the grayscale. Fourth process will be the enhancing the image with histogram, and the fifth one will be applying Gaussian smoothing, and the sixth one will be the image to the binary. So it can be converted into binary format using a thresholding technique. And the seventh process will be the segment oily and dry skin regions using k-means clustering. And the eighth process will be the displaying the result. And the ninth one will be the calculating the area of oily and drying skin. And finally, we can see the output of the results that are calculated with displaying in the console. So this is the image that we used for this project. So this is the code. So the code will be like loading the uploaded image in, and the second will be converting the image to the grayscale for easier processing. Third will be applying histogram equalization to improve the image contrast. And fourth, as usually we say, like applying Gaussian filter to smoothing the image. And the fifth one will be the convert the image to the binary using also method for thresholding.
The second part of the code is to apply morphological operation for to remove noise, and then we also used k-means clustering to segment the skin, to segment the pictures to to detect the oily skin and dry skin areas. And then we also used visualization in a 2x2 grid. So there'll be original image, enhanced image, and then dry skin visual, and then an oily skin visual also. As you can see, this is our code.
This is the third part of the curve. First, we calculate the percentage of the oily and dry skin areas, and the prints the calculate the percentage of the oily and dry skin areas. Then we generate the bar graph to visually represent the percentage of the oily and dry skin areas. Then we display the side-by-side histogram of the original and the enhanced grayscale image.
This will be the output and the explanation for the image. So for the left hand side is the original image that was the starting point of the analysis, and it shows a person's face capturing details like skin texture and features. And in the right side, the enhanced image was created by improving the contrast and reducing noise. And third one will be the oily skin areas that were detected using k-means clustering. And the fourth one will be the dry skin areas. So the dry skin areas also identify using k-means clustering. So this will be the image for first image of a bar graph, and the percentage of oily and dry skin areas. So the first bar represent the percentage of the image that classified as oily skin. The dry skin is represented by the second bar. So both bars are fairly similarly in height, indicating a relatively even distribution of oily and dry skin areas across the face in the image. This will be the histogram of original grayscale image, which will be in the left side. And the right side of the histogram of enhanced image shows the distribution of pixel intensity after applying histogram equalization. This will be the first image analysis. So for the oily skin area, the percentage will be 47.33%. And for the dry skin area, the percentage for the output shows that the 52.67 percentage.
Okay. The original image is show as the serve as the starting point before any processing or the segmentation step, and the enhanced image is using the techniques like histogram manipulation and also Gaussian filtering. And the oily skin areas has been segmented and identified using k-mean clustering. Dry screen areas identified using the same k-means clustering method. This is the bar graph for the image too. The oily skin is detected as a 49.84 percentage is and the 50% point 16 is a dry skin. Okay, this is the histogram for the image, the original grayscale image. And for the histogram on the right side, after the enhancement, the histogram reveals a more evenly spread distribution of pixel intensities. Okay, for the analysis, the oily skin is detected in the image is around 50.16 percentage, and also the 49.84 percentage is detected as a dry skin area.
So the conclusion of project will be to detect oily and dry skin areas. We applied histogram equalization and then Gaussian filtering and then K-means clustering. So what has been learned for us is the importance of image enhancement. Then we also learned how to use morphological operations to clean up the binary images, and then we also learned the effectiveness of k-means clustering. The advantages of our project is we successfully segmented oily and dry skin areas with, and then we also provided an automatic repeatable method for analyzing skin conditions, and we also used visualization techniques like histogram and bar graphs. But then we have few disadvantages of our project, which this method may not be work well to all skin type conditions. And then the k-means algorithm may not be perfect for skin type classification. And then the constraint of our project is it is limited by the quality and resolution of input images. And then our method also requires manual fine tuning of parameters like the size of Gaussian filter and the number of clusters in k-means. So overall, this project has demonstrated the potential for image processing techniques to analyze skin types, even though further improvements in algorithm accuracy and adaptability will be needed to practically apply this project in real world settings. For references, these are the references link that we used. So that's all from us. Thank you. So as you can see, this will be the demo of our project. So we'll try run with one advantage of this project also. So we used more than one picture in this project. Just for example, so we used two pictures to make the results more accurate and then more perfect. So we'll now run the first picture to upload and see. So as you can see, after we run the first code, we got three figures. As you can see, the first figure will be the images, which is the original image, enhanced image, oily skin areas, and dry skin areas. As you can see, we have four. And then the second figure will be the bar chart, where it displays the percentage of oily and dry skin. So the oily skin is you can see here for the both bar chart. The oily skin will be 47.3, and then the dry skin will be 52. And then as you can see, the third will be figure 3, which we have a histogram of the original image and then the histogram of enhanced image here also. As you can see, it's analysis here. These are the analysis for the first picture, where you can see the percentage for the dry skin and then the oily skin. And then now we'll show you the example for using the second picture. So you can see we'll run. As you can see, we have three figures also. As you can see, we have three figures, which is the first figure will be the images of the second image, as you can see. And then the second figure, you can see the percentage of oily and dry skin, which we have bar chart, bar graph, where it's nearly evenly separated. So you can see the oily skin is 49.8 percentage, and then the dry skin will be 50.1 percentage. Third figure, which is the histogram for the original grayscale image and histogram of enhanced image. And you can see the analysis for the second image is here. So that's all from us. Thank you.